On the 12th day of Christmas, Mr. Ing gave to me 12 perfect scores, 11 lessons learning, 10 steps for factoring 9.
Hey guys, 3.12 Introduction to Radical Function Word Problems. Well, how do you conquer the word problem? Well, number one, before you do anything, you got to plan. And I'll just say that I'm just going to emphasize it quite a bit. You really got to read this a couple of times. It might take you 2 or 3 times. Coding just basically means can you think of numbers or variables that you need. I like this one right here. This is basically draw a picture. Draw a picture. Ask a question. What is the problem asking? What would be a reasonable answer? Second thing is to solve it. This is like actually during it. Show your strategy, show your thinking. Are my strategies effective and efficient? Is there another way to solve it? I'm just going to write here really big. Is there a formula you can write down? Super helpful. Write down a formula, get those variables. Okay, and the last one, can you actually check your answer? Can you check your work? Go back to the question. Answer it in a clean sentence, and you can ask the question, did I answer the question? Does my answer make sense? You can also think of the units, okay? So those are just some quick strategies, things you should be thinking about for word problems. Be patient with it, but definitely reread it, draw a picture, and write down your formula. Thanks. Go to C1 here. Let's read this word problem and see if we can get some information out of it. We might have to read it a couple of times. The distance to the horizon is given by the equation d equals square root of h times d plus h, where h represents the height of the observer in feet. I'm going to highlight that. So h represents the height of the observer. So you'll notice that's actually twice. Okay. And d represents the diameter of the Earth in miles. Okay. Write the equation as a function of the height and use 7,918 miles as the diameter of the Earth. So they're telling us that. Calculate the distance Maria is from the horizon if she is standing on a hill that is 125 feet. 125 feet above sea level. Okay, so I have this. I'm gonna go back. And I know that she's 125 feet, so that's what I'm gonna use on my formula. So let's go ahead and just rewrite the formula here. Too thick. D equals the square root of h times d plus h. Okay, so calculate the distance Maria is. That's this d. So let's draw a picture. This might help. So there is a hill, 125 feet, and there's Maria. And we're trying to find that distance to the horizon. When I think of the horizon, I just think of, oh, pretty sunset. Okay, there's the sun. Okay, so let's just use this formula. The h in this formula is her h represents the height of the observer in feet. Well, we have 125, so let's go ahead and put that in there. Okay, we have to pay attention now. We're measured in feet for right now. Okay. And d, they're telling us, is the diameter of the Earth in miles. Okay, so here's my problem, is that this is in feet, This is in feet. And this one, let's just put it in there. This one is in miles, 7,918 miles. Okay, so here's the good news. This little information can help us convert it. So for 1 mile, and this is how I do mine. 1 mile is equal to 5,280 feet. Okay, so I'm going to make a proportion. It's basically just 2 fractions. And notice I'll have feet on one here at the bottom. And we'll do miles on the top. Okay, so if I have 7,918 miles, the question is, how much is that in feet? And you can just do this thing called cross multiplying. Basically, it's taking 2 steps at a time, saving 1. So just going to cross multiply. Let's do that one first. 1 times x is just 1x. And then if you do that same thing again, then you'll have 7,918 miles times 5,280 feet. Okay, so let's put that into our calculator. 7,918 times 5,280. Okay, it's going to give me some big amount here. 418,07040. And basically you put a comma for every 3 digits. Okay, so this is how many feet. Let's do this right here. Okay, this represents now the amount of the diameter measured in feet. Okay, so let's get all that in there. Remember, don't forget the square root, just like I did. Don't do that. Okay, we're going to take that number, 41,807,040 plus 125. So this was the green. And then I have 125. Order of operations, I'm going to do what's inside there first. So I'm just going to add 125 to that number. And you get it's basically the same number. But 165 now. And we're going to multiply that by 125, and then we're going to take the square root. So if I multiply this number by 125, I'm going to get some huge number. And now I'm going to take the square root of that number. And this is my answer. Okay, remember, we're in feet, and let's see. Write a function, we did that. Calculate the distance. Now it doesn't tell me if they want that in feet or if they want that in miles. Let me look at the answer, see what they have here. Okay, so they have both feet and miles. Let's just say you wanted miles. I would just, you can use the same conversion. Erase things you don't want. Okay, so how does this thing work? let's say you want that 72,290. You can cross multiply. That would just give you this number. And just multiply this one, put an x there. So 5,280x, so we're just going to divide this number by 5,280. This will cancel, and when you divide that, you will get approximately 13.7 miles. So 2 ways to get the answer here, feet and miles. Read the problem, draw yourself a picture, super helpful. This problem was a little bit difficult just because it had conversions in there. All right, C2, the relationship between the radius of a circle and its area is given in this equation. So let's write down that equation. R equals square root of A over pi. Okay, let's do some highlighting, super helpful. A represents the area of the circle, so that's this one right here. Write the equation as a function of the area and use 3.14 for pi. Calculate the radius of a circle with the area of 50.24. Okay, so they want us to do 2 things here. They first want me to write the equation as a function of the area. Basically, all that means is they want A equals. How do I kind of change this around? So how do I solve for A? So I'm going to get rid of this thing, so power of 2. So you're going to have r squared. This cancels, and the square root with the index cancels. And so you're left with A over pi. And then I'm just going to multiply both sides by pi. Oh, look at that. Do we know that formula? Pi's will cancel, and you're left with A equals pi r squared. Okay. All right, second thing, and it says use 3.14 pi. Okay. Second thing, calculate the radius of a circle. So calculate means what is the radius with an area. Okay, I got something. A for area is 50.24 square meters. Okay, don't worry about the square meters. Let's see if I can just cross that off. Don't worry about the square meters, okay? But worry about the 50.24. All right, let's write 50.24 here. Okay. Now it's telling me to use 3.14 for pi. And I don't think that's a really big deal, but we'll just do what they tell us. And we're trying to find r. Okay, so how do you solve for r here? Again, I'm going to use PEMDAS. And I am solving, so you're going to go this direction. There is no addition and subtraction. We're going to do multiplication and division first. So that means we're going to divide by 3.14. My pen is dying. Okay. So if I divide 50.24 by 3.14, I get 16. So that equals 1. R squared equals 16. And then basically, you're going to get rid of that by taking the square root. And some good math here is that it's actually equal to plus or minus 4. But r is radius, it's a distance, so it's really just r equals 4. Okay, so calculate the radius of a circle. We did that by solving for r. I solved for the formula there, and that's our answer. All right, C3. The relationship between the side length of a cube and its volume is given by the equation S equals cube root of V. Let's write that. S equals the cube root of V. Okay, now it's going to tell us some things. I'm using my highlighter. S represents the side length. So this S is the side length. That doesn't look like a V. And the V represents the highlighter, guys. V represents the volume of the cube. Write the equation as a function of the volume. Okay, this is step number 1. That just basically means solve for V. Solve for V. Get V by itself. V equals. So let's go ahead and do that together. I'm going to get rid of that cube root by cubing it on both sides. And what happens is this is going away and this index and the radical sign. So we are just left with S cubed equals V. And this here is number 1, write the equation as a function of the volume. So volume equals S to the 3rd power. Calculate the side length. I guess you really didn't need that, but let's write that volume formula again. S equals cube root of V. Calculate the side length. So this here is an unknown, right? That's telling you S equals what? Find it, calculate it. That has a volume of 343 cubic inches. Now, don't worry about the cubic inches. Just know that V is going to be 343. And again, if you need help with your calculator, let's go to my calculator. I'm using one looks like this. You can use ones I've shown you before. So I'm going to go to math, and then I'm going to do number 4. And then I'm going to type in 343 and press enter. 3 identical numbers that multiply to be 343. The answer is 7, right? 7 times 7 times 7 is 343, or 7 to the 3rd power is 343. So the answer is 7. And the units was just cubic, so that would just mean that the side length is 7, right? So if you draw yourself a cube, they're saying that each of these side lengths is 7. And what is volume? Well, if you have 7 here, and 7 there, multiply all those, then you get the volume of a cube. All right, let's go over this next one here. C4. The time it takes an object to fall a certain distance can be calculated using the equation T equals the square root of 2D over G. Let's just write that. T equals the square root of 2D over G. So let's pretend you're on some ladder here, and you're dropping something, and it's going to hit the floor. Okay, so it tells us D represents the distance, and G represents the force of gravity on a falling object. Write the equation as a function of the distance. So I already have that equation. And use 9.81 meters per second squared as a force of gravity. Use this one as a force of gravity. Okay, so again, don't worry about when it says meters per square. 9.8 meters per second squared. You don't need that. That's just like the units. So I just crossing it off because a lot of students will get confused with it. Okay, so it says calculate the distance. Okay, now we gotta look at this. Calculate the distance. So they want to know what d is equal to when an object will fall 3 seconds. So the object falling is your d value. No, I'll take that back. I say t is equal to 3. They didn't do a good job there, right? Because we know d is distance, g is gravity, but they didn't tell us what the letter t was in the formula, but this represents time. So that's why I wrote t equals 3. All right, let's put that in here. So I have time equals 3 square root 2 times, we don't know what d is, but we know what g is. That is 9.81. All right, let's go ahead and solve for this. Okay, so I gotta solve for d. Gotta get d by itself. I'm gonna square both sides. This will give me 9 equals. Remember, this 2 and there's an invisible 2 over here cancels with the radical sign. So that means we're just left with 2d over 9.81. Okay, here you can do a couple things. I'll just do it the slow way, or you could have just done solving proportions. So I see division, that's this thing, so I'm going to multiply both of these by 9.81. 9.81. Too many decimal points. Blah, 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 blah. Let's try that again. Okay, I'm going to multiply that. Okay. These are going away, and you're going to be left with 2d times 9. 9.81 times 9 gives me 88.29. Okay? And then we're going to divide by 2. This will give you d equals 88.29 divided by 2 gives me 44.145. This is a distance, so that's meters. Would be your unit. Okay, so what does that mean? We normally don't think of meter. So let's just say there's, if you have those meter sticks from your science class and it's 3 feet, that's 132 feet. I'm just trying to give you guys context or understanding, right? That means you're on some very tall platform. This thing, 132 feet. And that's like 13 floors. But here's the crazy thing, is that it is only taking 3 seconds to fall down. That does make sense, because you're on the 13th floor and you drop a penny, it's going to go pretty fast. Alright, C5 guys. The relationship between the radius of a sphere. Let's draw a sphere. I like drawing. Do you guys like drawing? Okay, radius of a sphere. So a sphere, you kind of draw a solid, and then another circle going around. That's more solid. And then the radius, let's just draw, goes from here to here. Guess you can also, I don't know if it works. But there's in green, and the surface area is given by the equation, let's write that one down, r equals square root of SA over 4 times pi. Okay, so if I went to, let's see what it tells us to do. Write the equation of the radius as a function of the surface area, which we have, and use, okay, so now it says use pi to be 3.14, so let's make that 3.14, and then it's telling you to calculate the surface area, so what is SA? So we basically keep those variables together. That's kind of weird, but back in your integrated 2 geometry class, that's what we needed. And then the radius is telling you r is equal to 4. Okay, so let's do some substitutions. That one's 4. We're trying to solve for SA, and we have 4 times this number. Okay. All right, so let's get rid of this radical. Okay, and if you need to, you can use PEMDAS. And I'm actually starting down here when you're solving. So there is no addition and subtraction. And multiplication, division, no. So we're now using exponents. So let's go ahead and use exponents. So power of 2. So that becomes 16. This 2 and this little 2 up here and the radical sign are going away. So now you're just left with SA over 4 times 3.14. Now you can multiply that number out if it's intimidating to you. I'm going to go ahead and multiply that out on mine. 4 times 3.14 gives me 12.56. So 16 equals SA over 12.56. And to get rid of that 12.56, that's division, so we're going to multiply both sides by 12.56. Multiply both sides by 12.56. Okay? We'll see that these will cancel, and then we're going to be left with SA equals 12.56 times 16, and that gives me a number of 296. So the surface area is 296. Surface area you don't need to know, but it is a area. So there's my answer. Height of a pyramid that is cut out of a cube is given by the equation S equals cube root of 3v. Okay, so you got a cube. I'm just gonna draw it because I like drawing. Cube. And go back and make it okay. Then they're saying I know what this one is. Okay, so then a pyramid, this is a, they didn't tell us, but I think they call this a rectangular based pyramid. So let's just say that's the top. Okay, so they're saying this green thing in there so the side lengths, let's go back to the math now. The side length of the base, this is the side length here in yellow. And the height of the pyramid, that is, okay, pay attention, that's to the bottom there, is the one that goes straight up and down there. And let's just write the formula they have. S equals cube, I could do a better job of 3's, of 3v. Where S represents the side length, so let's do our highlighting here. S represents the side length, side of the base, and the V, let's see, the V here represents the volume. Okay, write the equation for the side length as a function of volume. Okay, we have that. Calculate the volume of a pyramid with a side length of 4.2. Okay, so here they're telling us what is the volume. That's what we're solving for. That's what we can get by itself. In addition to that, determine the side length is, ooh, that's way too big. 4.2. Okay, that's too light now. 4.2. Okay, so the side length is going right there. Let's do that. So I have 4.2 equals 3v. Okay, all we're doing here now is solving for v. Using our math skills, we're going to do this to the power of 3 on both sides. That is my poor 3 there. This 3 and this 3 with the radical sign cancel or go away. Now I'm left with just 3v equals 4.2 to the third power. And you'll notice I didn't really work out that number yet. I like to leave it at the end. I call it a calculator-ready equation. Okay, so here, my 3's will cancel because 3 divided by 3 is 1. I'm going to be left with v, 4.2 to the third power. Um, 4.2 caret to the third power. And then we needed to divide that answer by what number? 3. So I don't touch anything, just write divided by 3. So the answer will just come up when you just press division. Enter. And that's bad. Give me a number. I'd rather have some decimals. 24,696. 24. So I have v equals 24.696. Okay, so volume. Let's look at what we have here. Is going to be centimeters and cubed. Okay, it just doesn't mean take the power 24.696 to the third power. It's just saying those are the units, units of measurements. Okay, and that's our answer. See you guys.
Rudolph the statistician, simple data everywhere.